Hello everybody, Happy New Year and welcome to a new video. In today's video I'm going to be recovering the gold from 20 Telecom boards. These boards all have Northern Telecom or Nortel written on them. I'm not sure what application they're out of, but they're supposed to be high yielding, so I'm sure we'll find out. So the first thing I need to do is depopulate these boards. I need to get all these chips, all these pins off. So I'll get set up for that and I'll get back to you in a minute and I'll make a start. Now, for anybody who's never seen me remove components before, I like to do it with a heat gun. I've just set my heat gun up in a retort stand. I've got a little beaker underneath. I'll just heat everything up and then scrape it off into the beaker, and then I can sort it from there. I'm going to sort the components into two different groups. First group will be the gold-plated material, and the second group will be all the chips and anything that needs incinerating. Okay, so we've got everything stripped. We've got 975 grams of chips, mostly these big flat packs. Almost a kilo. We have got 20 of these small processors, really thin. I had to get the solder off these and the heat sinks. There's some ceramic ICs and these little things. There's no gold bond wires, they look like aluminium on the inside of them, and then the inside of one of them little things, I don't know what that is, but whether you can see there are tiny little gold bond wires in there. So there's them, one processor with gold bond wires, and a ton of pins. There's good pins, fully plated, and there's these pins where just the tips are plated. So next I'll start the process of removing the tips. Just take them out into this little pot, and then one at a time snip the tips off so they'll look like that. It serves three purposes. Firstly, it removes all the tin solder. Secondly, it saves on nitric acid. And thirdly, it cuts down on waste solutions. Less nitric, less waste. So now all of the tips have been removed from the partially plated material. What I've been left with is a bunch of fully plated pins and sockets. Now I need to remove all the solder from these, all the tin solder, as I'm going to be using nitric acid. I'll just add the tin stripping solution. I have done a video on this, using this material, a separate video, so I'm not going to show it in this. I'll link it in the description. It's pretty simple. It just removes all of the tin, so we don't have any tin in there when we're using the nitric acid, which will cause metastatic acid, which is very difficult to filter. Now that the solder's been removed, I can add in all of the pin tips. That's all the pin tips I've got there. All them in. And then I can move on to the next item on the agenda. Set this to one side. Next up, we have the skinny little chips. Now what I found with these is it's easy to just rip off the solder pad on the bottom, and that leaves the chip behind on the heatsink. Just like that. And then with a heat gun, I can heat this up, pop the little chip off, and I'll throw that in. I'll throw all these little chips in with the ICs for incinerating. And then you can just pop that chip off with a blade once it's hot. Just remember that it is hot and don't try to pick it up with your fingers. So everything's now prepared for the gold recovery. We've got the pins on the left, chips on the right. Next thing to do is to incinerate these chips. Get them all turned to ash. You've seen me do that before. I don't need to show that. But with a snap of the fingers, all of them chips are incinerated. Turned to ash. Okay, time to get my grind on. Now I'm still using the same pestle and mortar that I've been using for the last 10 years. I'm considering getting some sort of flour mill or grinder. Let me know, what do you think? I know it'd be easier, but do you think I'd get... I'm scared of the losses with everything being thrown about, if I'm honest. Run it through a couple of screens. Keep going until everything goes through that second screen that needs to go through. And then what I'm left with is beautiful ash. Okay, so here's where I'm at. I've got the chips all crushed, and there's still a lot of copper wires in there that didn't come out when I was sieving. So I'm going to have to put some nitric acid in there. And there's all the pins. So next up, nitric acid into this one. Dissolve all the little bits of copper that are still in there. And then I'll probably filter the nitric off and then just pour it straight into there, just in case there's any free nitric, to dissolve the copper from these pins. And then I'll start dissolving them a bit later on. So outside we go. Okay, so I'm going to be using some of my homemade nitric acid. I'll just pour that in there. This is 33%, 34%. Made by bubbling nitrogen dioxide through water. I don't want to start with concentrated acid, just in case there's anything in there that might make it boil over. So if I don't get a vigorous reaction, I'll pour the rest in and then take it from there. It seems fine, so I'll just pour the rest in anyway. What I will do is I will stay outside and keep an eye on this one. With the lighter material sitting on the top and the bubbles that are formed, it likes to create a foam, which then traps more bubbles, which pushes more foam up. You need to stay out and keep knocking them bubbles away, stop it foaming over while the reaction's going. Okay, that reaction's done. I'm going to decant this off the top and give it a bit of a rinse through, and then run it through a filter and then throw it in with the pins, just in case there's any free nitric in there, just to help dissolve some of them pins away. The reason I like to get rid of all of the copper that's in the material is it makes the material easier to pan. I've started liking to pan this material. You can see small gold bond wires in there. I'm hoping for at least 1 gram out of the chips. A lot of them big flat packs don't have as much gold in there as you think they would. Yeah, they have like a large silicon die and the legs run really close to the silicon die, and then the gold bond wires, they only have to travel a short distance from the legs to the silicon die. So I'll get this set up for filtering. I'll get it filtered, and I'll get back to you in a minute. There's our nitric. Get that poured in. And I don't know whether you can see, but there is already an immediate reaction. There's some small bubbles going on in there. So I'll get this outside. I'll get it on the hot plate. I'll probably throw a bit more nitric in there. And then I'll make a start on washing, well, panning the chip ash. Now while this sits on here, as you can see, it's reacting away. I'll get back indoors and I'll make a start on panning the ash. Now I don't see very many people doing this, panning the chip ash. Most people just throw a bit of hydrochloric acid in, throw a bit of nitric in, and allow it to boil away. But I found that you use a hell of a lot more hydrochloric acid than's needed. If you can just concentrate everything down, you can do it all in 100 ml. And it's really easy. The first time I did this, first time I did any panning was with chip ash. I had no panning experience. And it's really simple. Throw it in the pan, 1 spoon at a time, little bit of water, and wash it back. You haven't got to be super aggressive with it, just gentle washes. And eventually you'll start seeing the gold appear at the top. Give it a couple of taps, brings the gold forward. Removing all the copper and all the other materials helps first. Because all that's in there now is the remaining ash, the crushed up silicon dyes, and the gold. Well, hopefully gold. You can already start to see the gold appearing at the top. I'll try and turn it so you can see. And all that at the top there is the small gold bond wires, which I can just grab now with a snuffer bottle, and I've got rid of all of that ash. I'll probably pan it through a second time just to make sure I've got everything. And then I'll do this 1 teaspoon at a time. Very therapeutic. Very much recommended. Right, back to the pins. Now, there's a lot of iron oxide sitting on top of that water. So I'm going to say there's a lot of iron in them pins, a lot of steel. The steel will eat all the nitric acid up really quickly. So I think with the bad weather that I'm having at the moment anyway, I'll put these in some old AP solution with an air bubbler and just bubble all that iron away. It'll probably be, it's going to be a lot cheaper than using litre after litre of nitric acid trying to dissolve them pins. Some of them have already dissolved. There's a few flakes in that, sitting in that water, but a lot of them haven't. But if you take a look, you can hardly see them, but they're all underneath those plastics. All of the sockets, they're still full of copper. There's some of them flakes floating around if you can see them. I definitely think the AP solution is going to be the way to go. So I have my old AP here. Pins in there. Some of it has flaked off, but as you can see, there's still a lot of material. I can leave this in the house. I can leave it to bubble away for a week. Morning guys, everything is filtered. These are the foils from all of the pins. I've already threw some potassium nitrate in there. And here we have the concentrates from the chip ash. As you can see, not a lot of material, so less acid to use. A bit of heat on ready. I'll probably put the acid in there first. I'm just going to put in 100 ml hydrochloric acid in this one, and I'll put 200 ml in with the foils, just because there's a lot of filters in there and there's a lot of material to cover. I'll leave these to sit for a while and then get back to you if there's any changes. Reactions are complete. There's no more bubbling. The solution on the right is very dark. Don't know why. Both test positive for gold, which is good. There's some orange staining on the stainless test for the pin materials, but I'm not sure whether that's just the colour of the solution just bleeding into the paper. I can't see where there should be any platinum in there. Right, let's get these solutions filtered and then I can get to a gold drop. I'm doing a quick filter first. I'm just pushing everything through a piece of gauze. This is going to trap a lot of the larger material. I find that gauze is brilliant for just doing a really quick filter, just to get rid of all that, all the mush from the filter papers, and you'll also capture some of the chip ash that was remaining in the concentrates. And then after that, I'll rinse it through with some water, squeeze it out, and then put it through a normal lab filter to clear the solution up. Now the solution, although dark, has cleared up really nice. Right, for the precipitation I'll be using ferrous sulfate, as always, it's my favourite. Just throw a couple of spoons in. There we go. Gold starting to precipitate. We'll throw another spoon in just to be on the safe side. And then I'll leave this to sit overnight. Gold's dropped. Whether you can see it there, there's definitely something in there, which is great. You can't top. We can have a better look at it. Yep, there's definitely gold there. Right, this needs a couple of washes and a couple of boils in hydrochloric acid. I'll leave that with me, and I'll be back with you when it's time to melt. Gold's cleaned up really nice. Looks beautiful. Today's melt I'll be doing with a Mac torch. I'm not using the microwave today. In there. Make sure we get everything. Sprinkle over a bit of borax. And fire up the torch. Starting with a slow flame, or low flame. Don't blow everything all over the place. And then once it's starting to melt, I'll turn the heat up a little. And see if I can melt a nice little button. Right, let's get this out. And here it is. It looks like there's a bit of a platinum shine on top of it. Or palladium maybe. There's definitely some contamination in there. Oops. Okay, let's get a weight. Here it is. Still not happy with that contamination, but what can you do, eh? And we have 1.6, 1.7. I'm not disappointed with that at all. Is that what you was expecting? Was you expecting a bit more? Let me know. And I'll see you on the next video.